Good evening, students. I think almost a week I'm meeting you all. So I was very busy with my schedule. So today I'm going to again send you the next video of Inorganic in 7 days. What are we going to learn today? So today we are going to learn the 63 facts of inorganic chemistry. So mostly these facts, most of the competitive exams or wherever you go, there's such particular questions, the whatever questions are discussed today, they will be asking you somewhere or other. These questions are repeated. So let's learn according to a sequence very clearly, and let's note in a book. So let's start off with a topic: 63 facts of inorganic chemistry. Right, students. So take out your book, take out your pen, and start noting along with me. Very easy to understand. Suppose whenever we study about inorganic chemistry, what are the different trends we speak about? So basically we talk about atomic size, density, melting point, ionization potential, boiling point, electron affinity, electron negativity, correct? So let us learn all the questions which come under these facts, right? So after this video there will be one more video, very interesting, that is I'll be discussing about the different trends of inorganic chemistry, where I'll be discussing about all these concepts along with all the variations shown in the whole of periodic table. So basically I've clubbed the periodic table and brought under one platform. Done. So when it comes to facts of inorganic chemistry, when I go with atomic size, right? So the first trend, as we know, is atomic size. So in atomic size, what questions are there? Let me put one listen for this square box and start. So basically in chemistry, what is the smallest atomic size element? So let us write smallest. I'm giving you a question based on atomic size. Smallest atomic size element. What is the smallest atomic size element? That is nothing but hydrogen. Let us put in circle. Suppose if I have to take the opposite of this, what is that? Largest atomic size element, largest atomic size element. So what is the largest atomic size element? It is nothing but cesium over smallest and largest. It is easy to remember like this, isn't it? Let us write smallest, largest like that. Next, after this, again the concept of smallest. If I have to take the next one, that is the smallest cation, right? I am writing the same thing here. So if I have to know what is the smallest cation in inorganic chemistry, smallest cation is H plus. Done, students. Now I have to write the largest anion. So when I have to write cation, anion, it's a negative charge and positive charge. So cation positive charge, anion negative charge always. So the largest anion or anionic size, so an anionic size or an anion is iodine minus. So the largest one is iodine minus. The smallest cation is H plus. Done. Let us come back to the next trend. After atomic size, let us go with electronegativity now. Right, let us start. Let me move the page a bit forward. Yeah, I'll put that electronegativity in the next column. So we very well know electronegativity, ability to pull or drag the electron from the outermost valence electron, isn't it? Valence shell, rather. Pull out the electron from the outermost shell. So in electronegativity, again two things we have. Let us write highest on that side. Let us write lowest on this side. So if I have to write the element with lowest electronegativity in periodic table is cesium. Okay, students. Next, the element with highest electronegativity is what? It's nothing but fluorine. Done. This fluorine further means after fluorine, the next element in the periodic table is oxygen. Correct? So oxygen is the next electronegative element. Done, students. Now let's come back to the next factor, that is electron affinity. So when I have to take electron affinity as the next concept, again I will take the same square box and learn two categories under this. What are this? I said lowest I'll take it on this side, highest I'll be taking on this side. Okay, students. So in the next video I'll be teaching what is electron affinity, what are the trends in the whole of periodic table. So when I take electron affinity on this side, I said we'll be writing the lowest electron affinity element. On this side I'll be writing highest electron affinity element. So when I take lowest electron affinity element, it would be nothing but noble gases. We very well know noble gases have lowest electron affinity. When I have to take the highest electron affinity element, it is nothing but chlorine is the highest electron affinity element. Now now we have atomic size over, electronegativity is over, now electron affinity is over. Let's start to write listen, what do you say after electron negativity? Okay, let me write electropositivity also. Okay, so after electronegativity, electropositivity is the next factor. So in electropositivity, let me put a box. We have written electronegativity in the earlier page here. Now I'm writing electropositivity. Again, as I told you, I'll be writing least on this side. I'll be writing highest on this side. So the element with least electropositivity is fluorine. The element with highest or most electropositivity is cesium. That's done. Yes. Now electronegativity over, electropositivity over, atomic size over, okay, electron affinity over. Let us write the next concept as ionization potential. Yes, right. So when I write ionization potential, let me take IP. Again in IP, I'll be writing both on this side and this. The element with the lowest ionization potential is cesium because the size is big. The element with highest ionization potential is helium because it is an inert gas. Isn't it, student? Now let us write with the next criteria. Let us come back. Now we have seen atomic size, we have seen electronegativity, we have seen electropositivity, we've also seen the trends in electron affinity. Means not the trends, basically the lowest and the maximum, the least to the highest element. Right. Now let's see a trend in melting point and boiling point. Suppose melting point if I have to take, and if I have to take boiling point. Then right, so in melting point, again let us write on this side, left hand side lowest. I like writing on this side. Now melting point, if I have to write highest. So when I take lowest melting point, right, and here lowest melting point and lowest the boiling point non-metal, lowest melting point and lowest boiling point non-metal, right. Next one, highest melting point and highest melting point as well as highest boiling point also. Lowest melting point, lowest boiling point non-metal is what? That's nothing but helium. Let us come back to this. Highest melting point and highest boiling point metal. What is that? It is nothing but mercury. Right, you're liking this, I think. Let's come back with boiling point. The element with or the non-metal with highest. So highest boiling point non-metal, highest boiling point non-metal, highest boiling point. Talking here only about highest boiling point non-metal. That's nothing but your carbon, right? So in that carbon, what is that form? That is nothing but diamond. The diamond form has the highest boiling point and it is a non-metal, because we very well know it's very difficult to break the diamond and boil it because of the strong bonds among them. Yes, students? Yes. Now let's come back to the next category. Let's see which is if I have to take hydrogen as an element. Now hydrogen is this element. What are the different names given to this? Basically in periodic table, hydrogen is known to be, means among this, it is the lightest element in the periodic table. Means hydrogen, when it is categorized, lightest element of the periodic table. This is also called notorious element, remember. So hydrogen is the lightest element as well as notorious element. When they ask you in the question, both the ways you can answer. Lightest is hydrogen, notorious element also is hydrogen. I think this is getting clear, students, to you all. Now what did we learn? We have learned atomic size, we have learned electronegativity, we have learned electropositivity, we have learned electron affinity, then I've taught you melting point, then I've taught you boiling point, then I have taught you what is the name given to hydrogen. Now let us speak in terms of conductor of electricity. Right, so when I have to write after hydrogen, let me shift my page a bit further up so that it's clear to you all. Yes, students, right. So now when I speak about conductance or conductor of electricity, so which conducts electricity, which allows the electrons to flow. So when I have to take, right, conductor of electricity, both the sides, the metal which is conductor of electricity is silver. The non-metal which is conductor of electricity Non-metal which is conductor of electricity is graphite. Hope this is clear, students. Metal conductor of electricity is silver. Non-metal conductor of electricity is graphite. Right. Let me take one more very important related to this. Poorest conductor of electricity. I should take that also. No, now we said conductor of electricity, and I have to see at the same time poorest conductor of electricity. So poorest conductor of electricity is what? As you know, it is nothing but diamond. Yeah, it has covalent bond formation in that. So covalent bond tightly packed. Hence, poorest conductor of electricity is diamond. This is over. Let me write one more. What is that? Now I'll be writing in terms of density. One more factor or one more concept of periodic elements. We study, right? Physical properties, chemical properties, the different parameters or the different characteristics of periodic table. So density is also one more. So the metal or the element which has density maximum in metals is osmium and iridium, and when I take in terms of non-metals, it is nothing but boron. Done, students? Is it clear? Oh, so nicely we have explained so many. Let's come back and go to the next category. Let me move my page above. Suppose if they ask me question in terms of abundance. Okay, so abundance in earth crust, abundance in universe, like that. So let us write the first category. The gas which is abundant means more in atmosphere. Gas abundant in atmosphere. What is that? It is nothing but nitrogen. Done. Right. Next one. The element abundant in Earth's crust. So let us write element abundant in Earth's crust. What is that? Nothing but oxygen. Done. Next. Element abundant in universe. Earth's crust is over. Now element abundant in Earth's crust is over, isn't it? Now let us write in universe. An element abundant in universe. What is that? It's nothing but hydrogen gas. Hydrogen. Now, I'll also teach you what is this rarest element in Earth's crust. I have to learn that also, isn't it? So, my charger fell down. Okay, right. So, rarest element in Earth's crust. Let us write that. Rarest element in Earth's crust. What is the rarest element in Earth's crust? It's nothing but astatine, AT. So, ASTATINE, astatine. Now, next, metal in Earth's crust. Means the abundant metal in Earth's crust. Abundant metal in Earth's crust. What is that? It is aluminium. Okay. Gas in Earth's atmosphere, abundant element in Earth's crust, abundant element in universe, abundant rarest element in Earth's crust. Not abundant, basically rarest element, right? And this is different. Rarest element in Earth's crust, astatine. Metal in Earth's crust, aluminium. I think all the information is there and under this page. Now I'll teach you one more in this. What is that? Basically, what did we learn? Let us recollect once. We have learned, I think, yeah, first one, we have studied about atomic size. Then we have studied about electron negativity, then electropositivity, electron affinity. Then we have studied about density. We have studied about what is the factor about hydrogen. Then we have studied about, elements like melting point, means the characteristics like melting point, boiling point, isn't it? Yes. Now, let's start off with one more concept, that is storage concept. Suppose if I have to store the element which you can store in water, that's nothing but phosphorus. Phosphorus. The element which you have to store in kerosene, that is nothing but 1A group elements. 1A group elements are there, isn't it? Except lithium. Except lithium, remaining all elements I can store in kerosene. Done, students. Now, let me start one more concept here. Amphoteric nature. Let us write that amphoteric. So abundance we have seen. Now we will see amphoteric. That means which the elements which react with both acid as well as base. Amphoteric in nature. Right. Now let us write here. First one. The amphoteric metal. What are the amphoteric metal we have? Which is beryllium. Zinc is amphoteric metal. Aluminium is amphoteric metal. Tin is amphoteric. Lead is amphoteric. The amphoteric oxide. What are the amphoteric oxides which we have? That is, we have BeO, Al2O3, ZnO, PbO, SnO, SnO2, Sb2O3, As2O3. All these are amphoteric oxides. Done. Next, what is an amphoteric metal oxide? Example of metal oxide, metalloid, which shows both the characteristics of the metal as well as non-metal. So the amphoteric metalloid which we have in the periodic table is silicon. Remember this, students. Yeah? Yes. Now, what is the next one? What category can I learn? In the periodic table. Okay. Basically, what is the largest element period? What is the smallest period? Right. Before that, let me go with the heaviest and lightest. Okay. Suppose, what is the heaviest natural occurring element? Heaviest naturally occurring element. Heaviest naturally occurring element. What is the heaviest naturally occurring element available? It is nothing but uranium. When I take heaviest, let us take with the lightest. Now this is heaviest. Let me take with the lightest. So lightest, same thing. Lightest solid metal. Okay, lightest solid metal. So the lightest solid metal which we have here is nothing but lithium. Okay, students, done. This is one category. Now I'll slowly go into a category like most abundant. Okay, so we have written more abundant. Now we will write most abundant. So when I take most abundant, means I'm talking about periodic table now. So in a periodic table, most abundant in periodic table, in S block, D block, like that we will write. So in periodic table, most abundant D block element is what? In P block or S block. So let us say S block. In S block, what is the most abundant element? I'll also teach you which is the most abundant gas in nature. Gas in atmosphere. So in S block, the most abundant element available is calcium. In D block, the most available element is iron. And the gas in atmosphere, the gas which is present abundant in atmosphere is nothing but nitrogen gas. Right, students? Yes. Now, let us speak something about the periodic table. In a periodic table, what is the smallest period? Let us write that. The smallest period, guess students, let me we very well know it. The smallest one would be the first period. How many does it have? It has only 2 elements. Correct? That is your hydrogen on this side, helium on that side. What is the largest period which we have? The largest period in the periodic table, that is the 6th period. How many elements are there? 32 elements are there in that. Right. Now let me start with the largest group. I should not say smallest group, isn't it? Nothing. All are equal here. So the largest group is nothing but 3b elements group. How many elements are there? There also 33 elements are there in the largest group. Right. I've studied about so many things today, isn't it? 63 facts I said. Okay, I'm trying to give all the data which I could get or collected from different sources. Right. Now, next thing, after largest, after smallest, after the concept of abundant element, let us start. What is one more concept? Means this is what dry. If they give you, what is that thing? Suppose what if they ask you what is dry bleacher? Means bleaching agent basically. If they ask you what is dry ice. So dry bleacher is nothing but hydrogen peroxide. Dry ice is nothing but solid carbon dioxide. This is done. Right, so dry beacher is hydrogen peroxide and dry ice is solid carbon dioxide. Hope this is clear, students. I'm not confusing you all. Because the concept here like this, if you study like this, it's easy for you. Yes, right. So here in density thing, we have written density earlier. Now let us see the same density if it is highest non-metal or highest metal. So I think in the earlier thing we have done this density concept, but here remember highest non-metal. Okay, let me write again, density concept. Density, what is the element with highest density, both highest only, highest non-metal, and which is the element which has highest metal. Means it is the same thing, but here I am writing in terms of non-metal and metal. So the element or the metal which highest density is nothing but osmium and iridium. The metal with highest density is osmium and iridium. Again, the metal with highest, means the non-metal with highest density is nothing but boron. Right, students, this is clear. I hope this is clear, students. Right, let me add some more to this today. I wanted all the information to reach to all my students, so I'm writing some more facts. What are they? So what are the noble metals which we have? What are the volatile metals in D block? What is a poisonous element? What is liquid non-metal? What is a lightest element? Like that. Let us note all those things. So if I have to add some more, what are the noble metals? It's nothing but gold and platinum. Noble elements everybody know. Zero group elements of group 18, that is helium, neon, argon, krypton and xenon. But here there was noble elements. Now let me write one more category. What are the volatile metals which we have in the periodic table? The two in D block. What are they? Zinc, cadmium, mercury, U and B. We write it as U and B. Biome. Bi means 2 students, 112 element, 112 element. Next, what is a poisonous element which we have? Poisonous element which we have, that's nothing but plutonium. So this also plutonium. Remember the students. Which is a non-metal which is liquid in state? So let us write that, liquid non-metal. So what is liquid non-metal? It's nothing but bromine. I'm sorry, not bromium, bromine. Next, the lightest element, as we know, it's nothing but hydrogen. I think I've mentioned it earlier. I'm writing it again. The lightest metal is nothing but hydrogen. They ask you what is the lightest metal, you should confidently say hydrogen is the lightest metal, because small things we think these are very small but nothing to remember. We have to, because such questions only will make us get close to the qualifying marks wherever you go. Right, next one, let us write what is the strongest base which we have. So in inorganic chemistry, the strongest base is cesium hydroxide. Now, strongest basic oxide. What is the strongest basic oxide? We will see. The strongest basic oxide is CS2O. Same thing. One more. Which is a stable carbonate which we have? Stable carbonate. Let us write stable carbonate. So the stable carbonate is cesium carbonate. Right. The element with highest oxidation state in the periodic table, highest oxidation state, is osmium. What is the oxidation state of osmium? It is +8. Remember that +8 is the oxidation state of osmium. Right, students? Yes, I think almost I've covered all the listen. If anything is missed out, let us come back. Something is missed out. Let me cover that also. Right. So group with maximum gaseous elements. Let us write that. Group with, I told 63 facts, so let me cover that. Group with maximum gaseous elements. So which is the group which has maximum gaseous elements? In that they're asking. So the group is the last group, that is group 18 elements. So in group 18 is a group which we have maximum elements. That is group 18. What do you call it? It is nothing but zero group. Helium, neon, argon, krypton and xenon. Right. Next, what are the total number of gaseous elements in periodic table? Total number of gaseous elements in periodic table. Gaseous elements in periodic table. Basically 11 gaseous elements are there. What are they? Hydrogen, nitrogen, oxygen, fluorine, chlorine, helium, neon, argon, krypton and xenon. Right, students? Yes. Right. Next important thing. Okay, how many did I write? 3, 6, 3, 6, 9, 10. Okay, 10. I'm sorry. Next, students. Which is the total number of liquid elements? Okay, let me write that. Total number of elements which are in liquid state, liquid elements. So basically, if I have to write, there are 6. What are they? Gallium, cesium, francium, barium, mercury and UNB. Atomic number element 112 in the periodic table. Right, students? Now, one more let us add to our book. What is that? An element means an element which is liquid and it is radioactive. Okay. Let us write liquid element. I should not write like this, but I'm just for your clear understanding. Liquid element which is radioactive. So it is francium. Confidently you can say francium. Next, how many total radioactive elements we have in the periodic table? Basically 25 radioactive elements are there. Total number of radioactive elements. How many? 25 are there. So now, what is a volatile D block element in this? Okay, we said there are liquids. So what is a volatile D block element which we have? Let us write that. So volatile D block element. So volatile D block element which we have is zinc, cadmium, mercury. Okay, done. So with the students, I think I've covered almost all the concepts of inorganic chemistry. I have made almost 4 to 5 pages. Thank you for watching, students. With this, I've covered 63 important facts of inorganic chemistry. So in my next video, very interesting video, it will be little bit time. You'll watch this video completely. In that, I'll be teaching you different trends in periodic table. After that, according to your request, I'll be doing the structures in periodic table. Understood, students? So signing off here with the important facts of inorganic chemistry in the periodic table. 63 facts, important 63 facts in periodic table, or 63 facts of inorganic chemistry. Lot of time it took for me to collect, but thank you so much for watching, students. Practice all these things. I'll meet you again in the next video with the trends in a different way, in a different sequence. You'll understand, you'll love the concept basically. Thank you. Good night. Bye-bye.